All right. Hello, Dr. Sanders. This is Tim Allec, and I'm going to be demoing the work I contributed to the black hole within my code. Um, I worked with Daryl, Phineas, Tino, and Manalik. To get started, I'm just going to run through a quick simulation of my scene. So, as you can see, we had the lensing effect with the sphere in the middle, creating this, and then we also have a the disk around it as well, which is another it allows for the lensing effect. We were trying to get it to where there's a circle around the black hole, the lensing effect, and then there's a disk like around it, but we didn't get that far. But as you can see, we do have the interstellar ship right here, which is texturized, and then we have the star background, which is texturized, as well as we had a planet. And we're still working on rendering that with the whole sequence. But this is my demo for today. And if we go ahead and go into the code, so if we go to what I contributed down here, so this is us basically just creating the size for the ray, beginning right here. So we're tracing the ray through the kernel, and we have a grid size X and Y and a block size X and Y. This is just with the JCUDA driver launching the kernel and initializing the ray tracing. And then after we do that, this is when we get into the load object to GPU function. So I worked a lot with getting the ship texturized and actually loaded into our rendering frames, which was a tedious process, but you know it was an important one. So we load the model data with the string path. So this string path is the path to our OBJ file, which is the interstellar ship. So we create an OBJ loader, which is another file that we use to load the OBJ object and the triangles into the GPU. So we have a function called load triangles with UVs, which is within this code, which accounts for every single triangle on the ship, and then it maps with the texture with that ship, and then we set the scale to 0.075. So the ship is pretty big, but to fit into our rendering, I had to scale it down quite a bit. We initialize triangle data equals the mesh dot vertices, and text coordinate data equals mesh dot texture chords. So this is just making sure that the triangle data and the texture coordinates, they line up with each other. And then right here, we allocate the memory for the JCUDA driver with the text coordinates, and then the text coordinate data is multiplied by the size of the float. And then down here, we have JCUDA driver copying into memory the texture coordinates. And then we also have these pointers, which are pointing to the kernel's parameters, um, text cord data. So just ensuring that um, our CUDA file interacts properly with the kernel file and the way that the kernel has been compiled. Down here, we initialize the position of the ship. So x equals 10, y equals 2, offset z equals 20. And then we have a loop. So for I is less than the triangle data dot length. So this is just basically iterating through all the triangles within our ship. And then we add 9 to it. And then we have a nested for loop, which is the V. So this is basically just getting the OBJ file, the V value, all of the V values from the OBJ file. and then while it's less than 3, and then we iterate through the v's, and then we initialize an integer index, which is I plus v multiplied by 3 for the different faces of the triangle. And then we have float vert, which is initialized as a float. And then the triangle data index minus offset x, and then we do the same for offset y and offset z. So this is just ensuring that the offset of the ship is aligned with the triangle data. Down here we have rotations for the ship, so ensuring that it's facing the proper way. Down here we have the triangle data, basically the same thing up here, but we just have the vert added to it. And then we return this new model data, which takes in the triangle data and the texture coordinates. We have two exceptions. So one if we load the OBJ file wrong, and then another one if it's just any other error. And then we return null for that. And then we have public static class model data. So this is where we define the model data and how it should be used. So we have initialized triangle data, the texture coordinates, and then with public model data, the parameters are the triangle data, and the texture coordinates. So we're just basically saying that this triangle data equals this triangle data, and this texture coordinates equals the texture coordinates. And then down here we have our object loader. So this is the file that we use to actually load the triangles from the OBJ file. Object mesh is just a class which identifies the vertices and the coordinates for the texture mapping to the triangles. We have 9 floats per triangle, and then 6 floats per triangle for the texture coordinates. And this is our load triangles with UV, so this is very important for make sure that the triangles are loaded with the proper texturing. So we initialize different lists for positions, the UVs, the final verts, and the final text, which textures. And then we do a new buffer reader, so we're reading the file path of the texture. Of the object file. And then while line is not equal null, we just continue this loop, this while loop. If the line starts with v, we split it a certain way. If the line starts with vt, we split it a certain way. And then if the line starts with f, we split it a certain way. This is because this is the structure of our obj file, has like lots of lines of v and then vt and then f. This is essential for uv mapping. And then we also have a for loop right here. So while I is less than or equal to 3, and we iterate through I, and then we just parse the different parts just to ensure that the v and the vt and the uv are all, the f are all being parsed properly. And then we just add those positions to the indexes. And then down here we have another for loop, which just iterates to the final vert size, and then it just flattens the different positions. As you can see right here, we have it for V0, V1, and V2. Then down here, another for loop for getting the which loops through the final texture size. So this is basically making sure that t equals the final textures get at whatever I we're iterating through within the for loop. And then we map the UVs with that. And then object mesh, again, we're just creating a new object mesh object. And then in here, this is the start of the kernel. So as you can see, we import math, q to runtime, pi. These are just initializing some basic operators for a kernel. So as you can see, for a float operator, like adding floats, subtracting floats, multiplying floats. And then we also have division of floats, and then or dot of floats. So it's basically just defining simple operands for the kernel. And then we have some other simple functions like normalize or get the length of these different float values. And then clamp is here, which takes in the V and the minimum val, maximum val, and then we get the min of the maximum of the whatever is inside of here. So the x, y, z plus the minimum value for that, either x, y, z, and then cross product, another initialization for that as well. Absolute value, radiation color approximation. So this is basically just colorizing based on the Kelvin temperature, because we're making sure that the black hole is in regards to heat. Orange from dark orange to light orange. So based upon what temperature in Kelvin it is. If the temperature is less than 1,000 degrees, it's dark orange. If the temperature is above 3,000 degrees, it's like more so like a midish orange. And then if the temperature is above 6,000, it's like a bright orange. So it's very hot. And then, yep, that is the code I contributed. And here's one last look at the demo.